Hey everyone, and in this class we are going to learn how to interface RFID module with Arduino. Now this right here in your camera is RFID module. I am going to attach few pictures here. These RFID technology is basically very commonly used in security gates. Anywhere if you want to swipe card and identify a person, you can use RFID tags. You can use these for attendance machines if you want to make one using Arduino. These RFID tags and modules are even used in industries. So we are going to learn how to interface this module with Arduino. Hopefully my camera and yes, audio, everything is clear in this class. Let's start. First of all, let me attach a picture here on your screen about how to connect RFID module with Arduino. This is the wiring diagram. You have to connect these wires exactly the same. There are few wires that you can change, like these MOSI, MISO and other pins. These pins should be connected to their assigned pins as per this diagram. Why is that? Because this RFID modules communicate via SPI communication, and these are the pins assigned for SPI communication with Arduino UNO. In Arduino Mega, different pins are assigned for SPI communication. Okay, so let's learn about some communication modules first. Before we jump into that, first learn about communication modules. I am going to attach few pictures on your screen. There are two very common types of communications are used with Arduino. One is SPI communication, other one is I2C communication. In Arduino UNO, pin number 10, 11, 12, 13 are assigned for SPI communication. So if any module like this RFID module, like your USB host shield, like NRF module, I am attaching the picture here on my screen. All these modules communicate via SPI communication. You will connect them via pin number 10, 11, 12, 13. There are some modules like timer module, like I2C, like this 16x2 LCD and other modules. They communicate via I2C communication. So if any device is if you learn that this device communicates via I2C communication, that device will be connected with A4 and A5 of Arduino UNO and pin number, I guess, yes, 20 and 21 of Arduino Mega. Alright, these pins are assigned for a specific purpose. So let's say here, if I intend to connect a device that communicates via I2C communication, I will connect that device here on my pin number 20, which one? 21 and 20. These are assigned for, these are named as SDA and SCL. Now I have RFID module. This module communicates via SPI communication. So I am going to connect all these pins as per wiring diagram. So let's fast forward and connect these pins. First I will connect this RFID module with my breadboard like this, as you can see in your screen. For Arduino Mega, the SDA should be connected with 9, then SCK 52, MOSI 51, MISO 50, IRQ should not be, it's not connected, then ground with ground, reset with pin 8 and 3.3 volt for 3.3 volt. So I have connected all of wires as per this diagram, and remember the first one, the 3.3 volt should be connected with 3.3 volt of Arduino. Some sensors, some modules operates at 3.3 volt. It's also in standard, so you should connect this with 3.3 volt, not VIN, not 5 volt, 3.3 volt, and ground will be connected with ground, and all other respective data pins will be connected with their respective pins. Now we have code here, but I am not going to copy this code. I already have compiled a very simple code. You will get its link in description, and yes, I am going to open that code. There are two codes here. We are going to understand one by one. The first one is RFID hold data. The second one is RFID with condition. So RFID hold data will extract the data from our cards. How RFID works? If I swap my card like this, as you can see, let me unpack it. If I swipe my card like this here with my module, it will detect the code of this card and display that code on my screen. So let's say I have two cards, two different types of. This one is a keychain, small keychain, and this one is a card. So if I swap this keychain, it is going to show me a different code. If I swap this card, it is going to display a different code. I can differentiate between these codes with if conditions, and I will say if I swap this card name, it should mark the attendance for, let's suppose, John, and if I swap this card, it should mark the attendance for Mike. So, and yes, we can add more cards. All right, so I'm going to place these card on my screen right here. Let's open our code. It's the same code from that site, from that website, but a little bit more simplified. So what we have here, we have an SPI library, then we have an RFID library. So you know how to install the libraries. I'm going to give you a link in the description about RFID library. If you already have downloaded the library and you want that library to be included in your code, what you have to do, you can go to Sketch here. In Sketch, go to Include Library and click on this add.zip library. You open this folder, you will have something like this. Then you can go to like your downloads. Then you can go to downloads like this, and in your downloads you will have your library that I have provided in the notes, in the project files. You can download that library, include that library, and it will be here like this, include rfid.h. This RFID library takes all the functions that are essential to use this module. Let me connect my Arduino as well. Now as you can see, red LED is also glowing in my RFID module. That means it's connected. If it doesn't glow, that means you have done something wrong in the connection. Recheck your connection, recheck again, and if you will do everything right, it will glow like this. Then we have our this function, creating an object like this, like we have done in sonar sensor, like we have done in servo. So this creates RC522. This is the name of this module, and it will create an object with this name. And we have connected our SDA pin with pin 9 and reset pin with pin 8. If you change these pins, you can change it here. Now let's move forward. In our setup, we have serial begin 9600. It will initialize the communication between our computer and Arduino. Then we have SPI begin. SPI begins will initialize the communication between this module and this Arduino. Serial begin will start the communication between us and Arduino. Then SPI.begin will start the communication between this module and Arduino. So Arduino is the central hub, it's a brain. It is communicating with all this stuff. It is communicating with module, it is communicating with us, it is taking the readings from this module and will display those readings on our computer screen. So you need to begin all these types of communication. Then we have if RC522.start. When we swipe any card on our module, in our loop we have initialized a if condition. If RC522 is card, when there is a card on it, read the reading of that card and print all those readings on our screen. This for loop, we have discussed for loop before. This for loop will run 5 times and it will take 5 integers from our card and display those integers on our screen. We are going to look at how it will work. Nothing else. The code ends here and we can upload this code now. So go to tools. Yes, our Arduino is connected. Let's upload this code. Yes, the code is being uploaded. And let me adjust my screen. Open a serial monitor, take it here. Now the serial monitor is empty. Why? Because when we swipe our card, it will show something. So if everything is right, it will show some readings. Yes, as soon as I swipe my card, it shows me reading 83, 56, 148, 50. These are the 5 numbers. These are the 5 decimal numbers of this card. We can get readings in the form of hex number as well. This right here, this DEC denotes that the readings will be in decimal. So we are getting these numbers in the decimal form. So if I swipe it again, it will show me that card detected, same number again and again whenever I swipe this card. But if I swipe my keychain, look at that. Now readings change. So if I swap another card, if I get more card, if I purchase more card, 5 more cards, all those 5 cards will show me different types of reading. Now remember, what are the readings? 83 for the white card and 193 for keychain. So I cannot differentiate between these. I am simply going to use the first number and I will differentiate using that number. It's not a right approach, but it's a simpler approach for a small project. So if you learn how to do that, later on you will learn how to use all 5 of them. But if I entangle you in some loops that you need to compare all 5 readings in the for loop, you need to make that loop, you will get confused, you will not be able to understand that. Let's keep it in mind that 83 is for card, 193 is for keychain. Let's apply some condition. So I already have a prepared code right here, RFID with condition. Open this code and let's take this code from here. It's the same code again. See, everything is same, SPI.h, RFID.h, everything 910. Then we have initialized the function. Then everything is same in the setup. But what is the difference here? We are not taking readings here. If we have created an integer named as code, that code is taking the reading number 0. In array, number 0 is your first integer, number 1 is your second integer, number 2 is your third integer. So we are taking the first number here into the code, and if that number is 241, do this. If that number is 49, do this, and then our codes end right here. So the number we are getting with our RFID is not 241 and 49. This one was for my previous RFID module that I was using for a different project right here. We are going to change this number. If we write something like this here, what was our number? 83 and 193, I guess. Am I right? Yes, 193 and 83. So if I use this number, when I swipe 83, pin number 19 will be high. When I swipe 193, pin number 19 will be low. And this is how you can apply condition. I have just provided you the exact code in the description. It will make your life very easy to, if you want to use RFID module, believe me, you will not find something that simple on internet. So all you need to do, you need to first of all upload the previous code, this whole data code. You upload this code, you swipe your card, you will get those integers. After you get those integers, you write them down, keep it, remember, if you have 10 cards, swipe all 10 of them, remember their name. After that, open the second code, you have to upload this code and you can apply condition. If the first integer is this one, do this. If the first integer is this one, do this. But what if the first integer of 2 cards is same? Then you have to take readings of the second integer. And how you can do that? You can change this symbol 0 to 1. Now it will compare the second integer. You can also compare all 5 of them if you want more security. Let's say you want to apply it in the industrial scale. But I know that if you are right here in this course and you are attending these classes still here, that means you are a learner, you are a beginner, then you don't have to get confused with all of that stuff, all of those arrays and etc. You should be able to enjoy this course. If you are understanding all these concepts, now you are enjoying, and if you are enjoying, you will eventually learn all other advanced stuff as well. So I am not going to attach anything right now with pin number 19. So I will write serial dot print here condition 1. So if I swipe my, let's say not condition 1, it will write white card. Alright, and in my 193 I am going to write blue keychain. Alright, if it works fine, it will display white card when I swipe the card, and it will display blue keychain if I swipe the keychain. Let's press Ctrl U to upload this code. And okay, now as code is uploaded, let's open our serial monitor right here and let's swipe the card. Okay, as you can see, it is displaying white card. If I swipe this one, it's displaying blue keychain again. White card, yes, white card, again blue keychain. It will keep working like that. Download the codes, upload this code, and you should be able to do this. After that, I am going to add some more stuff in this class. We are going to build a small mini project. We have learned how to use servo and we have learned how to use RFID. I am going to integrate both of them together to give you a better understanding. So let's stop it right here. Let's close this code. And now what else I am going to do? I am going to add the condition here, include servo dot. I am going to add a library here, include servo.h. Now I have included the library of servo right in this code. We are combining two different codes. Then here we are going to initialize my servo and name it as my servo, as we have done in our previous class. I am just naming my servo as my servo. Alright, then in setup I will write my servo dot attach, and I will attach this servo with pin number 4, let's say. So I will attach my servo motor with pin number 4. Let's grab a servo motor here. Now you can see it's on my screen. Hopefully you can see that on my screen. Let me take something like, give you a better idea. Yes, hopefully now you can see this servo motor here, and I will attach a battery as well. I need a battery. If I want to use a motor, I need a battery. So I have my small battery here. I will attach this battery with Arduino, and I have my servo motor here. Okay. Now let's move forward. I will attach my servo with pin number 4. I will wire it with pin number 4, and in our loop, we only have to write my servo dot write, and I will give it angle of something like 150. If I swap my card 83, then it should open a gate for 3 seconds and close it. So my servo dot write 150 display all these readings, and then here I will write something like delay of 2000, wait for 2 seconds, and then I will write my servo dot write. I will take my screen from there to here now. Alright, so I will write my servo dot write and something like 0 and wait for 100 milliseconds then. Okay, so if I swap my white card, then it will open the gate for 2 seconds and close it. But what if I swap the blue keychain? It should say at 0, the gate will stay at 0. If I swap my blue keychain, it will not open. But if I swap my white card, it will definitely open. What else I am going to do? I will take this RGB light as well. This right here. We have used this light as well, so I am combining all of these stuff. So I have RGB module, RGB light here as well. I will attach this module with pin number 9. I will attach this red LED with pin number 9. So if I swipe the wrong keychain, the wrong code, it will make this LED glow. Otherwise it should not glow. It will make this red LED glow for 2 seconds and then close it. If I swipe right card at RFID module, it will open the gate. If I swipe wrong card or keychain, it will not only close the gate but also glow red LED for alert. So this is the complete project. It can be your semester project at college. So let's say we have completed our code. Let's just upload this code. We have our pin number 19, yes, pin number 19 for LED and pin number 4 for servo motor. Let's remember that because I have to connect these, and let's upload this code first of all. Alright, the code is now uploaded. Now I have to connect the servo and RGB module. Okay, so I have connected my servo and RGB module with Arduino, and I have connected two LEDs instead of one, only red LED. I have connected the green LED with pin number 18, red with pin number 19 as we have mentioned in our code, and servo with pin number 4. And remember, if we connect it a lot of stuff, then we need a battery. Our computer cannot provide the sufficient power, so I am going to connect my battery as well here to the Arduino. And I am going to disconnect my computer. Now it's a portable project. It's not connected. It is not connected with any wire around. So let's just open the button of the battery. Everything is on now, and you can see servo motor in your camera. This right here is servo motor, and this is a red LED here, and this right here is our RFID module. Hopefully everything is clear in your screen. Okay, now let's try if it works or not. I am just trying it first time. Now yes, now it works. Gate is closed. Whenever I swipe the white card, gate open. After 2 seconds, gate will be closed. If I swipe my wrong keychain, it should turn the LED on, the red LED. So if I swipe this keychain, yes, instead of red, it is glowing blue because I might have connected the blue one by mistake. So let's check if I connected it to blue. Yes, I have connected this one to blue. So let's take this one. I have changed the wires. I have connected that LED with blue before. Now swipe the wrong keychain. Okay, now red LED is glowing and it will close after 2 seconds. If I swipe my right card, it will turn the servo on for 2 seconds. Everything is working fine. Let's just add one more stuff. But if I want to add one more stuff, I have to connect my Arduino with my computer again, just like this. I am just demonstrating all of this for you. When you start making projects, actually it will start looking like this in your screen. There will be a lot of wires, breadboard, connectors, battery, and so much other stuff. So let's just stop right here, and I am going to add one more pin mode 18 output for my green LED. Okay, I have connected this green LED of RGB module as well. When I swipe the right keychain here, in the condition number 83, I am going to add not only my servo.write 150 but also turn the other LED on, pin number 18, not output, high. Make pin number 18 high. Alright, and yes, after 2 seconds, pin number 18 should be low. Alright, so if I swipe the right key, right card, green LED will glow as well. Let's upload the code. Okay, now if I swipe the right card, green LED glows. As you can see, if I swipe the wrong keychain, it will turn the red LED on, just like this. Okay, it's working fine. And in the close-up, you can see if I swipe the correct card, it should turn the yes, it turned the gate on and with green LED. We can increase the duration while the gate was on by increasing the delay on that specific condition. Let's try it again. Yes, it's working fine, cool. And if I swap this card, then the red LED will glow. This project can be named as a security door using RFID module. This can be a college project for Arduino for microcontrollers project, and you have the code right here. Let's just say I'm going to save this code as RFID with conditions 2. And this marks the end of our this class. Hopefully you have enjoyed it, and again this one was interesting and a new and important class. So if you are confused about anything, before going to the next one, rewind this class, and if you are still confused with anything, there might be some questions I left unanswered, then you can ask them in the discussion tab. This is Shah Fahad Ahmed, your trainer, and I will see you in the next class.